Hi guys, welcome back to In Case of Econ Struggles. Welcome to another game theory struggle. Today we're going to be talking about adverse selection, but we are going to be talking about the more mathy version of adverse selection. So rather than using game trees and extensive forms of games, today we're going to be talking about the profit maximization problem and the utility maximization problem. But we are still talking about the same adverse selection concept. So there will still be two types. Only one side of the market will know that private information or those types, and the other side will not. And we are trying to think about how the adverse selection problem will be solved. Today, the way we're going to do that is we're going to talk about it in the context of an airline. An airline is going to be selling two types of tickets to two different types of customers, and they are trying to elicit from the customer what type of flyer they are. In addition to that, what we're going to talk about is we are going to do a game tree. It won't be a formal game tree. It'll be more informal just to get a sense of what's happening. Then we're going to talk about the nitty-gritty of the adverse selection problem in this more mathy version. We're going to talk about two types of constraints, the individual rationality constraint and the incentive compatibility constraint. We are going to set up the adverse selection problem. We are not going to solve it in this video due to length. If you would like to see a full solve of an adverse selection problem, make sure to comment below. Timestamps are below in the description if you would like to jump around, but let's go ahead and start talking about this airline. This airline is going to be a made-up airline. I call them Spirit Airlines. Now, we are also going to say that there are two types of people in the world. There are bills. There are X% of bills in the world. Bills love to fly. We say they have a type which is equal to H or a high type. The rest of the people, or 1 minus X% of the world, are Daves. Dave is pretty meh about flying. We'll give him a theta or a type being L or low. Now, Bill and Dave each know their type, but Ferret does not know what type each person is. They don't know if they're dealing with a Bill or a Dave. So what Ferret is going to do is they're going to offer two types of tickets. We'll call one type fly levers ticket and the other a basic economy ticket with no reference to any airline in particular on that. And what we are going to allow Ferret to do is we're going to allow them to charge different prices for those tickets and set different perks. So maybe for a fly lever, you can choose your seat. You get to board relatively early. Basic economy, you get whatever's last. You're boarding last. You probably won't have that overhead space. We're going to say that Bill and Dave have a utility function. I'm not going to be super specific about that function. I'm just going to say it's some function of the price, of the quality, and of their type. And we are going to say that the utility of not flying is 0 for Bill and Dave, just to make it easier. And we are also going to say that Ferret wants to maximize their profit. That's coming straight out of the profit maximization problem. We are also going to say that if Ferret wants to give people more perks, so if the fly levers has more perks, it's going to cost Ferret more to give those perks. Now, let's think about how Ferret wants to win. So we're going to pretend that we are Ferret Airlines and we're trying to maximize our profit. What are we going to do? How do we think that we've won? Well, Bill is going to choose to fly. Bill loves flying. We want Bill to fly because he's probably willing to pay more for a ticket. He's going to buy that fly levers ticket, and that's what we want him to do. He's going to pay the price of the fly levers ticket. Now, for Dave, we are kind of indifferent about whether Dave flies, but we definitely want him to fly at the basic economy because Dave is not willing to pay that fly levers price because he feels pretty meh about flying. So he can either fly basic economy or he doesn't fly. It's not super important to us because we're really targeting those bills of the world. Now, Ferret could lose, on the other hand, by Bill flying for basic economy. So that means he's paying less. And we really want Bill to be paying more because Bill is willing to pay more because Bill loves flying. And again, in that same situation, if Dave doesn't fly, then Ferret has really lost on both ends on that. Now, let's think about the game tree. I just think this is useful as a visual for what we just talked about. So all we're saying is that if you are a Bill, from Ferret's perspective, we want you to not only fly, we want you to fly for a fly levers price and at a fly levers ticket. If you are a Dave, so you are a low type, then, we would like you to fly. And if you fly, we want you on the basic economy, but we're not super sad if you decide not to fly and you just stay home. So that is the setup of this problem. Now we're going to start talking about our first constraint, which is the individual rationality constraint. All the individual rationality constraint means is that the utility of flying must be at least as good as staying home. And that's all this is going to say. So if that is the case, we know that the utility of not flying for them is 0. So we have greater than or equal to 0 here and greater than or equal to 0 here. Note that we say the individual rationality constraint is binding if it's strictly equal to 0. Now, in addition to this constraint, we said that we want Bill, if he flies, to go for fly levers, and Dave, if he flies, to go for basic economy. And we lose if Bill chooses to fly basic economy because, again, we want Bill really on that fly levers ticket. So what that is going to mean is that for this incentive compatibility constraint, if Bill flies, Bill chooses that fly levers ticket, which means that the utility for Bill of the fly levers ticket needs to be at least as good as the utility to Bill of the basic economy ticket, which means that we're just going to fill this in here. So if I am Bill and I choose a fly levers ticket, that needs to be at least as good as Bill choosing to buy a basic economy ticket. And for Dave, Dave needs the opposite. Dave wants to be at least as happy flying basic economy as Dave is to choose that fly levers price. Now we are going to put this all together and set up the adverse selection problem formally. So now let's go ahead and set it up. So it's a profit maximization problem. So we are trying to max. What can we choose? Well, if we're Fear-It, we can choose the price of flight levers. We can choose the quality or the perks in flight levers. We can choose the price of the basic economy ticket, and we can also choose the perks of the basic economy ticket. Okay, there are X% of bills in the world. So here's this X%. And we are going to gain the revenue, but we have to pay for those perks. And the other thing is we have 1 minus X Daves in the world, and we are getting the price of the basic economy, but we have to pay for those perks. So our profit maximization looks like this. And then we are subject to all of these constraints. So we're subject to the individual compatibility constraint for Bill and Dave, and the individual rationality constraint for Bill or Dave. The way you solve this problem, and the reason we're not going to do it in this video, is because the way you solve it is you basically test different combinations of these constraints binding, and you see which one yields different results. Now, that is a lot, but there are some that you can start with that are generally good to do. So generally, it's good to check that the individual rationality constraint of Bill binds, which means he just barely chooses to fly, and the incentive compatibility constraint of Bill as well. So you make it so that Bill just flies and Bill just barely chooses that fly levers ticket. You can also check that same thing for Dave. There are other combinations that you should check as well, but those are some good ones if you're in a pinch. So hopefully this gives you a better sense of how to set up the adverse selection problem, how it works in a more mathy version. If it was, make sure to like and subscribe, and we will see you next time for another case of econ struggles.